people believe that our brain is sleeping when we're asleep. And by sleeping, they mean inactive, doing nothing. And that is absolutely not the case. The most important point that I hope you take away from this talk is that sleep is not a time of inactivity for your brain. In fact, in some states and in some areas of your brain, the brain is more active in sleep than it is during wakefulness. And it's busy doing work that can't be done in the waking brain. So when you deny yourself of the time for sleep to do its work, or sleep gets otherwise derailed from its task, there can be harsh consequences. Sleep is something we all do, or we die. And this has been the case since probably life began. Why? Because of great research over the last 100 years, and especially since REM sleep was identified about 70 years ago in the 1950s, we know a lot more about what is happening and what it's all for. Sleep is serious business, essential to life. It's a time of high activity and tons of work. Nearly every mental health disorder is characterized by sleep disturbance, and that's true of neurological disorders as well. So schizophrenia, depression, post-traumatic stress disorder, other anxiety disorders, autism, Parkinson's, Alzheimer's disease, even drug addiction. All of these are characterized by sleep disturbance. Why must we and every other animal put ourselves in such a vulnerable state? My best analogy is that sleep is a time when we clean up, organize, and put things away after the wild party of waking. And we must clean up and organize every day, or the next day's activity and function will be inefficient and full of errors. If enough days go by that we haven't done the proper cleaning of our brains start to look like a hoarder's house. So in this analogy, waking is like that big party. And the amount of mess that's created is directly proportionate to the amount of adaptive work that we do when we're awake. When we're adults, our party of waking is more like a birthday party, where guests are eating food and bringing gifts. But when we're learning a lot, like when we're in school and when our brains are changing when we're teenagers, waking is more like a housewarming party where guests are bringing more serious gifts like plants and dishes and even furniture. And when we're first born, when we're babies, that party in our brains when we're awake is more like a serious house construction party or a barn raising party where the guests are bringing things like cement and fences and plans for major construction jobs. This heavy-duty construction allows us in sleep to shape our brains in accordance with the environment in which we are born. The stages of sleep are consistent throughout our lives, although we do get a lot more of these last two stages of sleep, REM sleep and the N2 transition to REM sleep, when we're younger. From waking, here in yellow, we go into stage N2 and then N3, deep sleep. That's where we have rhythmic breathing and regular heart rate variability, and we have these big, slow waves of electricity that sweep through our brain. Then we go back into stage N2 sleep, which here is called the transition to REM, with these funny electrical signatures that we call sleep spindles. They last a second or two and come several times a minute. Interestingly, the frequency with which they occur corresponds with our intelligence and our ability to improve our learning through sleep. Then we go into REM sleep, here in red, which is our dream state. It has a rhythm called theta that shows up just like it appears when we're awake and learning new things. And what does each state with its funny electrical signature do? Well, in slow wave sleep, our brain is cleaning through the slow waves which sweep debris into the lymphatic system, which is the garbage removal system of our brain. We're also restoring metabolic balance in several ways, including converting adenosine, which builds up in our brain during wakefulness, into ATP energy packets. and we're restoring the power generators of our cells. All of this is like restocking our kitchens after our party guests have depleted the food in our house. Finally, in slow wave sleep, we are building proteins. The construction work that stabilizes new memories, or it does the more serious brain schema building work during development, the plans for which were laid in waking. In the transition to REM sleep state, we are integrating and consolidating our memories through sleep spindles. We're transferring memories in a coherent and cohesive fashion, like integrating the gifts that our guests have brought into the decor of our house, or filing the important information that they brought in the right place. REM sleep gets the task of cleaning up through those theta waves, which weaken old connections that are made redundant by the new things, freeing space in our brains for new items to come in the next day. This is also a state when we take stock of what we have and rearrange. We try out new connections and new combinations to create new insights. And we do this by strengthening the new connections. These functions all need to happen in cycles because, like restoring after a big party, you can't see what needs to be integrated and cleaned until the bulk garbage is cleared, and the process of cleaning and throwing out old redundant items makes new trash that we need to throw out again. And we go back and forth again and again until the job is done and we wake up. If you go to bed too late, well, then you'll miss the garbage removal and construction and repair jobs of slow wave sleep. Also, the size and strength of our slow waves get smaller as we get older, making us more susceptible to neurological diseases like Parkinson's and Alzheimer's, where the garbage of misfolded proteins is not cleared away. And if you consistently wake up too early or have sleep that doesn't allow you good REM sleep, well, you'll miss the putting things away and removing redundancies, part of transition to REM and REM sleep. You also don't want your different specialist crews, the construction crews, the heavy-duty cleaning crews, the designers and decorators, to all wield their tools in the same space at the same time. The effect would be chaotic and inefficient, and probably someone would get hurt. That kind of chaos is what happens when we're sleep deprived. All the states are fighting for the same precious bit of time, trying to do their jobs on top of each other. The sleep-deprived situation results in dissociated states, which can be frightening to the parents, for example, watching their child in a night terror, where your emotional system is active, although the child is unconscious and doesn't remember it, or scary to the sleeper, like sleep paralysis, when atonia, which is a paralyzed state that prevents us from acting out our dreams, is on, but we are awake and conscious. Or confusional arousals where we're dreaming and conscious at the same time. Sometimes these dissociated states can be downright dangerous, like sleepwalking and REM behavior disorder, where atonia isn't working and we act out our dreams, no matter how wild those dreams can be. We used to think that only mammals and birds had these two different states of sleep, but in fact, if one looks carefully at every creature that sleeps, well, we can see that every animal studied, from whales to worms, all seem to have at least two stages of sleep. One slow, regular, and relaxed, and the other with a very active brain, except without atonia. Even the lowly jellyfish have a state of sleep, hours, where they're pulsing at half the waking rate, and they're less responsive to stimuli, and they need to make up time in this state if they're deprived of some of it. And another state of sleep where they're completely inert for 20 seconds at a time. This last discovery is so new, we don't even have a name for this state yet. What would you call it? Is this like our REM sleep state where our muscles are paralyzed while we're dreaming? Are jellyfish dreaming too? In those of us with eyes that move, our eye muscles are not subject to the paralysis of REM sleep, so they can move around in accordance with our dream content, which is why we call this dreaming state rapid eye movement sleep or REM sleep. Every time we're awake, even if we're just watching TV or reading, our brain is rearranging itself, accessing and acquiring a lot of information. Every thought requires taking information out of our memory banks, like books off of a bookshelf. And if we're to keep an organized brain, we have to be putting these things away again, carefully, in an organized fashion. And if we learn something new, and the analogy here would be like a guest bringing us a book for our library, well, we'll have to integrate that into our existing library in a coherent fashion, or we'll never be able to find it again. This only happens during sleep. When we are young, these sleep jobs are critical, like I alluded to before, more like a barn-raising construction job than cleaning up after a party. Our brains have to make brand new connections and clear away those things that we're born with but find that are not relevant as we learn what is and what is not in the world around us. For example, we don't know how to walk when we're first born, but our brain is wired to expect and to adapt to almost anything. That process of learning where our limbs are and what they do and how they coordinate requires us to prune away connections as well as form new ones in order to learn to walk efficiently. This selective process only happens in REM sleep, which is present in spades during early development. When we're first born, about 50% of our sleep state is REM sleep, when this selective, experience-dependent pruning occurs. And at least 50% of our non-REM sleep state is that transition to REM spindle state, where we're integrating everything together. Even as adults, when we're learning something new, like the new place perhaps our husband has stashed the chocolate bars in our kitchen, we have to, in sleep, incorporate that new information into our schema and erase the old connections that are no longer relevant. In schizophrenia, these sleep spindles that integrate new information in an orderly fashion are missing. And so it's not surprising that what's true and what's not real would get so mixed up. Also, if we don't have good REM sleep, we can't prune away the irrelevant synapses. That would create confusion about what we should do and what we shouldn't do in a new situation. One neurotransmitter that's normally gone in REM sleep is norepinephrine. This is important because whenever norepinephrine is present, it allows only synapses to be strengthened. And remember, REM sleep is a time when we want to prune away those synapses that are unnecessary and that carry irrelevant information. In PTSD, it appears that norepinephrine hangs around in REM sleep, preventing that important memory clearing function, which may be why traumatic memories feel more like they happened yesterday in PTSD instead of years ago. Norepinephrine also prevents those long integrating sleep spindles, which is why probably exposure therapy doesn't work as well as we thought it should, because old mental pathways dominate. Just imagine when you're in the theater of war, the sight and sound and approach of a helicopter might reasonably be associated in your brain with something dangerous like dropping bombs or spraying bullets. And the right thing to do in that situation is to duck and run. Get out of the way, right? But when you come home or that war is over and you're in a safer environment, you will want to reassociate the sight and sound and approach of a helicopter with something that in that environment, in that context, is probably a lot safer, like a news helicopter. If you aren't able to distinguish between those two contexts, well, you're going to be confused and not know what to do, whether to duck and run or to just go about your business calmly. These important sleep functions are why it's crucial to guard your sleep environment and your schedule, and especially guard your child's sleep, including your teenagers' sleep, with jealous zeal. Sleep is an incredibly active time in our brains, where memories are stabilized and integrated, our schema, scaffolds are being built, especially during development, or revised when we're adults, and the mess created in waking is being cleaned up. Remember, it's imperative for you to do this rebuilding, organizing, cleaning work every day, or there will be undesired consequences, like bad decisions or accidents. There is ample scientific evidence that poor sleep can lead to long-term health consequences, like post-traumatic stress disorder or schizophrenia or dementia. Trying to function on a night of sleep deprivation is like trying to throw a second party when the mess of the first party has not yet been cleared away. and the cleaning crew is in there together with the guests of the party, all clashing and fighting for the same space at the same time, causing confusion and inefficiencies and even injuries. If I leave you with one thing, it's this. Sleep is every bit as important for your long-term health and well-being, including your emotional well-being, as nutrition and exercise. Make it a priority, like you do with food and exercise. Thanks so much for listening. Now go get busy sleeping and sweet dreams.